Alright, for these two, we're going to do these a little bit different than we learned last time, but it's very much related to this equation stuff that you guys remember. Y2 minus a y1 all over x2 minus a x1 radical. So it's extremely similar to this, but also extremely different, which we will see. Radical. So the sloppage, let's get rid of this garbage because we don't like it. The sloppage is always going to be a fraction. This is nice. Something that people like about these is that, well, we could use rainbows. And rainbows, when they're doubled up, have been known to make people cry. So, see how it was the change in the y's in the numerator? So we're going to show a rainbow connecting the y's above, which is because the numerator is above. And to go from 19 to 10, you'd have to go down 9er. So our numerator is that change down 9er. Radical. Well, the change in the x's is from 3 to 4. And to go from 3 to 4, you just add 1. That's the denominator, which is the change in the x's, which is why it's in the bottom. That rainbow's in the bottom there. Because it's the change in the x's, which is in the denominator. Negative 9 divided by negative 1 is negative 9. But if you like it in the fraction form, that's fine. So since this is rainbow method, it is a little bit different. We went from left to right. But what you're saying is true with the difference in the equation. You could go right to left. So let's try that on the next one, okay? I always go from left to right, so I will never demonstrate this from right to left after this example, okay? So for example, we got this fraction radical. And to go from negative 5 to 8, I would have to go up 13. So that right there is the numerator, up 13 radical. And then to go from 6 to negative 3, I would have to go downwards by 9. So it's a negative, or to the left 9, if you will. Well, this radical is a fraction which will work, and the decimal would be looking very awfulness. So yeah, how did I get, so you're asking how I got a 13. Yeah, so I went from negative 5, which is below 0, and I went up to 0 and then up 8 more, which means I had to add 13 to negative 5 to get to 8. Well, I went upwards. On the y line, it's up and down, right? Yeah, so, yeah, the number 1, I went from the left point to the right one. But this shows you can go from the right point to the left point as well. It's not going to matter. Here's the only difference on number 2, okay? Let's say on number 2, we went from negative 3, 8, 2, 6, negative 5. The only difference is that in your fraction, you'd get negative 13 over positive 9. These are the same. They are exactly the same, and you'd get both of them correct either way. Calculate the sloppage of the line that contains the points given in each table. And as we saw on the bell work, you do not need more than 2 points. But fortunately for us, they've given us 4 for each of the tables. That was very generous. Calculate the sloppage twice, because doing it once is just not fun enough. By using the sloppage formula with 2 points, and the other time by finding the rate of change or unit rate in the table. So just as a quick review up in here, remember the equation is y2 minus a y1 over x2 minus a x1 radical.
That means x.
Alright, let's do 1 and 3 together. Well, number 1, again, we only need 2 points. So which 2 points do you guys want to use?
Both of those.
3, negative 5, and 5, negative 8. Sound good. So the equation, y2 minus a y1 all over x2 minus a x1.
Yeah, why is it y2 minus y1? Why isn't it just y over x?
It's a good question. All right. Well, it's a change. It's a difference of those values. So the first value, what?
Would it be negative 5 plus 8?
Let's find out. The second value we chose was 5, negative 8, right? So my y value there is negative 8. So that's my y2. Going to be negative 8. And my x2 value would be the x value of that point, which were 5 right here. Well, then the first point we had, my y value, it were 3. Oh, the y value is negative 5, sorry. I'm looking at that all wrong. Negative 5, and then the x value were 3. No, that's better.
That's a 5, not a 3.
I was looking at this x value. Alright.
Don't the negatives cancel themselves out?
Yep.
Yes.
Negatives make a.
That minus and negative will change to a big fat plus sign right here. That way we don't have to think about that opposite of minus and opposite of positive garbage. And we can solve with these. Negative 8 plus 5 are negative 3. 5 minus 3 is 2, and that is as simplified as we go on this fraction. So now I'm going to use that rainbow method, but instead of them being side by side, they're above and below each other.
So it'll be a vertical.
So, yeah, it's going to be like a vertical type rainbow. But we got to go back here, and it doesn't matter which 2 points we choose because it's a constant rate of change. Which 2 points do you guys want to use?
3 and 5. 11.
3 and negative 5? Well, you want to use the same 2 again. Okay, that's fine. All right. My rainbows will always go downwards, and again, this is going to be a fraction. So from negative 5 to negative 8, I would have to subtract 3. That there is the numerator. Now the denominator is the change in the x's. 3 to 5, I would have to add 2. So my denominator is a positive 2. We can see that these two are the same sloppages. Because it don't matter how you do it. Let's do number 3 up in here. Let's use the equation y2 minus a y1 and the next 2 minus an x1. Which 2 points do you guys want to use? These the 2 top ones again?
Yeah.
Oh, that's kind of bland, but whatever.
Well, first you said not to use colorful.
Yeah, that's true. So my y2 value is a 9er, and my x2 value, the second point there, is got a 3 right here, because it was a 3 9er. Then I got a y1, which is also 9er, and then my x1 right here is a 0. So when we compute this, 9 minus 9 is 0. 3 minus 3 are 0.
So would it be infinity?
It's 3.
Oh, it's 3?
0 divided by 3 is 0. You can put that in the calculator, we'll tell you. So this sloppage right here is 0. But what if we was going to use let's use those other two, 6 and 9 and 9 and 9er.
Why don't you minus 9?
Which we will see now that we're using a rainbow method. So from 9 to 9, we would have to add exactly 0. And from 0 to, I said I was going to use other points, right? Let's go back.
Just don't use other points.
Let's go from 9 to 9, and then from 6 to 9er, bam, 3. 0 divided by 3, this may come as a surprise, but it is 0. And both of our sloppages are the same. So if we were to see this on a graph, since we can see that the sloppage is 0, what type of line would it be? It would be exactly horizontal this way. Anyone still need this stuff?
If there was a 0 on the top.
Number 2. Which 2 points do you guys want me to use on this one?
1, 9, and 2, 14.
1, 9, and 2, 14. Let's do it. So we're going to use the equation y2 minus a y1. Then we got x2 minus a x1 right here. And which one do you guys want to be point number 2?
0.
1 and 9.
1 9er. This will be number 2, so this has to be number 1 point. And yes, I am doing this a little bit different. So number 2, my y value are 9er. And my x value are 1. So on my y1 value, it's going to be 14. And then my x1 value is its corresponding x value 2. Like at these. Well, 9 minus 14, bam, negative 5. 1 minus 2, negative 1. If I were to simplify, I get 5. Using some rainbow method, because it's our favorite, because we can draw some rainbows up in the count. Well, let's use the two endpoints. From 4 to 19, looks like I would have to add 15, right? So I have to add 15 right account. And from 0 to 3, I would have to add 3. That's a positive 3 right account. 15 divided by 3 are 5 as well. Same sloppage, different methods. Bam. I like me some rainbows too. I like that there's a pot of gold at the end of the rainbow.
I like just the answers.
So, yeah, me too. Which is what we have right now. What about this next in right account? So we can use equation method right account. Right? Y2 minus y1 over x2 minus x1, like at these. And which 2 points do you guys want to use?
The negative 3 ones.
The top two. Yeah, the negative 3 one.
There's no negative 3, 1.
I mean, the one that has negative 3 in it.
Yeah, negative 3 and what?
4.
Negative 3, 4.
And negative 328.
Bam, sounds good. All right. So we got negative 3, 4 and negative 320. And we're going to replace these in this equation. Which point do you guys want to be the number 2 point?
The 3 and 4.
The top one. Bam. That right there is its y value is 4 and its x value negative 3. Which means that this y1, x1 will be replaced with the other values, which are 20 and also negative 3. So when we solve these, 4 minus 20 is negative 16. Negative 3 minus negative 3, right, we'll change that to plus 0. Negative 16 divided by 0 is 0. No, it is not 0. It is infinity, which means it would be undefined. Now on the homework it showed it with the 0 through it, with the slash through it like these.
0 divided by something.
Long division, which is so fun. This is what you do. Let's make this negative 16. Let's just make it 16 divided by 0. This is 16 divided by 0, long division. How many times does 0 go into 1? Infinite number of times.
Which means it's a 0.
Which is already undefined. We don't even have to worry about that stinking 6. And that is why it is undefined. So as long as you know how to do long division, you should be able to do this. With these, now we got to do the rainbow method. We'll use the other 2 points. So this will be a fraction. How far is it from 12 to 28? You'd add 16, right? How far is it from negative 3 to 3? 0. 16 over 0 we already seen, undefined. Are the sloppages the same no matter what 2 points you use to find the sloppage? Since the rate of change is constant, meaning it changes the same each time, like if we were to reduce those fractions always, that means the rate of change is constant, which is why it is a straight line, making it linear. Yep, that is why it does not matter which 2 points we use or where we use them in the equation. Gourmet jelly beans cost $9 for 2 pounds.
That is correct.
Well, these are gourmet ones, you know, like the ones that taste like boogers. You know what I'm talking about? Or like frog spit.
Like Bean Boozled.
Gourmet chocolate is gross. Like that special chocolate.
I like chocolate,
It's amazing.
but not in jelly beans. It's weird.
Yeah, chocolate jelly beans is weird.
Yeah, right?
And chocolate popcorn. I mean popcorn.
So weird. Well, these are not those jelly beans. These ones are gourmet ones, which people pay $9 for 2 pounds for. Okay, which is good. You know, if they're
Wait, 2
you know,
pounds for $9. That is
how great is that?
bargain.
Yeah. I prefer steak for that price, but whatever. Anyways, these ones are $9 for 2 pounds. So we're gonna fill in this table. We'll make the graph, and then we'll answer some questions. Here's the nice thing about this is right here, they told us at the top that it's $9 for 2 pounds. So if I had $9, like it shows in this second column right here, how many pounds could I buy?
You could buy infinite.
2. Because it told us it was $9 for 2 pounds. Well, if that were the case, then how much would it cost for half a pound? That's close. So 2 pounds is $9. So 1 pound for $50, right? So half of that would be $2.25. Very good. So if I wanted 3 pound, how much would it cost? Bam. $13.50. How much for 4 pound? 18 buck. How about 27 bucks? How many pounds could I buy? 6. How much how much would it cost for 8 pounds?
36.
36 bucks. And 10 pound? 48. Isn't it? Oh, I mean, yeah, gosh. 45, dang it. What about 20 pound? 20 pounds? 90. Very good.
Wait, for 15 it's $90?
For this empty box, this empty column right here, it's asking really for some variable amount of pounds. So I'm going to use X for these. So I need to figure out how much it would cost to get X number of pounds. Well, we want it in terms of the pounds. So it should be something multiplied by the X is what it's really saying right there. So what would I multiply by X to figure out my costs?
9.
3.14.
So like 20 pounds, I just did 20 times 9 to get 90? 4.5, excellent. How'd you get that? How'd you get 4.5? Very good. For 1 pound, right, we remember it's $2 for 2 pounds for $9. So 1 pound would be $4.50 right here. So keep that in mind. Alright, no, they love it. It's great. Alright, for the graph. Before we make this graph, we're going to need to label the xi first. So, for example, we talked a little bit about this last time. If we know the independent variable, then it's the x values. If we know the dependent variables, then it's y values. So which of these depends on the other? Does the amount of pounds you get depend on the cost, or will the cost depend on the pounds? The cost depends on the pounds. So, for these, we're going to have a cost right here. Cost. And then the pounds is going to be the x. So this is going to be the number of pounds. All right. Now that we have that labeled, we need a scale. We went up to 20. So 20 pounds. Looks like if we have everyone go up by 1, we should be good. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right. The cost goes all the way up to $90. So if we made each of these worth 10, then we'd be in good shape. But we can manipulate this so that all the points will land on the corners of the grid. So I'm going to have each of these Y lines go up by 9er, starting with 0. So 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. You guys have heard that song before? With the, with the crab and the whale. Yeah, like, no.
I drew a picture.
It's the counting song. It, goes up and, no. You have it all wrong. You are doing it all wrong. Well, now that we got that, now that we have the scale and these X I labeled, and let's put these points on this graph. So at 0.5 we had 2.25, which would be right about here. For 2 we had 9. For 3 we was up to where 18. No, 13.5 right there. 4 was 18. 6 was 27. 8 was 36 right here. 10 was 45, and then 20 we was up to 90 right here. And then we have that expression stuff. And we could put all these other points. That was the nice thing about the way that we did it. But now that we have all these points, would we connect the points with a line?
No.
The question for this really is, is it possible to buy like a quarter of a pound of gourmet jelly beans? Yes, it is. And can you pay $0.25 for the jelly beans? Yes, you can. So, we will connect these points. But it's important to remember that this would continue on forever and ever. So we do have a line there at the end, an arrow at the end of the line. All right, what is the sloppage of this line? We did figure it out. The sloppage is 4.5. As a fraction, you can make it 9/2 as well. Write the slope of the line as a context that describes the slope of this context. Okay, well, you can get, for $9, you can get 2 pounds. That would be the fractional way. Or for $4.50, you get 1 pound.
Wait, if you work 0.
Cost of the for a certain amount of jelly beans. Alright, so we need to describe first what the X and the Y will be. And we can see from the graph that X is number of pounds and Y will be the cost in dollars. So if I want to find my cost, what do? Well, I can take $4.50 and multiply it by the number of pounds. We found that up here. And that would do it. That would be fine. Why is the data graphed only in quadrant 1? This is only in quadrant 1 because you can't buy negative pounds of jelly beans. It has nothing to do with the absolute value necessarily. It has to do with the context. You can't buy negative number of pounds of jelly beans. Mr. Irving and Miss Hendrickson play. They don't play babysitter. They pay babysitters differently. Okay. Well, anyways, let's look at old Irving right here. There is something different about these. Irving is going to pay you $0. And then Hendrickson for 0 hours is going to pay you $4. This is a good idea if you want to get people to, come and just babysit, because I'll pay you $4 and for God for 30 minutes, bam, you get the $4 and some extra. All right, are both these relationships proportional? Well, we got to look back and figure out how to figure out if they are proportional. Well, for Irving, which I will do in red, the number of dollars divided by the number of hours, because the amount of dollars depends on the hours, so that's our numerator. That's undefined. That's okay, but we got to go to the next value. Undefined. The next value, we got $9 for 1 hour, which simplifies to $9er. And then for $27, you would get paid for 3 hours, which simplifies to 9. So far, that looks like a proportional relationship once it shows up. But for 5 hours, you're going to get $45, which also simplifies to 9. So right now we can see that Irving is a proportional relationship. All right, what about old Hendrickson,
No.
which I will do in Playboy. Hendrickson is going to give you $4 for 0 hours, which comes out as undefined. That's not a problem.
Might you just
But for $12, you would have worked 1 hour, which simplifies to 12. And then for $28, you would have worked 3 hours, and that simplifies to 9.3 repeaton. Those two are not equivalent. Therefore, you can see that Hendrickson is not proportional. There it is. This graph, we're going to use the table up in here, and we can see that the dollars depends on the hours. Graph both of these at the same time. All right, now that we have these, I will graph Irving in red again. That'd be good. So for for 0 hours, you get $0 right here. And for 1 hour, you're gonna get $9. 2 hours would be 18, which would be about right here. 3 hours and $27. 4 hours and 36. And 5 hours and 45. So there we go with this one. And then we also have Hendrickson, which starts at 0 hours, $4, right about right here. And then 1 hour is $12, right about here. And then 3 hours is 28, yeah, about right there, it's above. And then 5 hours is 44, to be about right here. And so if we draw the lines for these, oh, that's not the right line. Here's the line, there we go. There's that one for Hendrickson. And then we got the one for Irving, like these. Sloppage of each line. Well, let's figure out the sloppage for old Irving. I'm going to use rainbow method. It goes up 9. And then to the right 1. 9 over 1 is old Niner. Hendrickson, however, goes up 8. I'm just using these first 2 points. And then goes up 1. 8 over 1 is 8. In context of this problem, though, the sloppage has different meanings for both of these. Only in value, though. Irving is going to pay you $9 per hour, while Hendrickson will pay you $8 per hour. The different Y-intercepts is how much they're starting you at. Is one babysitting job better than the other? Yes. Unless you're working for 4 hours, then they are the same. Once you go beyond 4 hours, then it would be better to work for Irving because you'll get paid more. If it's between 0 and 4 hours, though, then it would be better to work for Hendrickson. All right, let's write the equation real quick and so we can get the homework out. So the Irving, again, the Y is the pay in dollars. X is the number of hours. And then Irving, the pay is 0 because that's how much they start you, plus $9 for every hour, 9 times X. Hendrickson, the pay is going to be $4 to start with, plus $8 for every hour. Just multiply these together. All right, before we go over and start the worksheet, I want to go over some examples of the sloppage stuff with 2 points because it may help us with today's lesson, finding sloppage from a table. So you guys give me some values of these points.
6 and 3.
3 is what I heard. What else?
6.
6. 4.
15.
15.
9.
Bam. There we go. That'll do. That's all I need. All right. So if we have 2 points, this method is much different than what we learned, but it is also extremely similar. This is called the rainbow method for finding sloppage.
Rainbows.
Yeah. Yeah. Actually, like double rainbows,
Oh,
which have been known to make grown men cry and weep. You guys know what I'm talking about there, right?
Isn't that one video like
Yeah, the guy starts crying and stuff, and then we all laughed at him. All right. In any case, this is how this works. So your sloppage is always going to be some kind of fraction like these, right?
Yeah.
Well, we can tell from the poster, you guys remember this garbage? Y2 minus y1 over
That's
x2
too
minus
big.
x1. You guys remember this stuff?
Kind of.
Well, you see how the y's are in the numerator, the difference between the y's? Well, we're going to do the same thing, but we're going to connect them with this little rainbow like these. Yeah, I know, some people hate this rainbow because it's very not curvy. So you can make it as curvy as you want, like these, if you really want to.
Or make it squiggle.
So we're going from the point on the left to the point on the right, because that's kind of how we read. So from 6 to 15, what would you do to 6 to get to 15? You're going to add something. What? Niner. Yep, you've just added 9. Bam, you found your numerator for your sloppage. What about your denominator? From 3 to 4, see the double rainbow right there? You would have added Juan. So 9 over Juan. What is the sloppage on these? Simplify. 9. I mean, if you want to write 9 over 1, that's fine. But this is kind of like using this equation stuff without actually using the equation stuff. Which is pretty nice because not everyone likes the equation stuff. People like rainbows. They're very pretty, you know. And at the end of each rainbow, what is there? Bam, a pot of gold. So right here, there is a pot of gold.
Gold's favorite.
And possibly me Lucky Charms.
To chip you out.
Nope, I've seen the end of a rainbow, and there was a pot of gold.
Try me.
But I chose the Lucky Charms instead. I guess this is quite appropriate because we talked about rate of change, right? Now we're talking about the old Irish Lucky Charms. So this leads us to this pot of gold. Yeah, you guys love it, right? Calculate the sloppage of the line that contains the points given in each table. Calculate the sloppage twice. One time by using slope formula with 2 points, and the other time by finding the rate of change or unit rate in the tables. Okay. Alright, fine, whatever. So the first way is to use that equation stuff, right? Where we got the difference of the y's and the difference of the x's. So right here, we just got to use any 2 points. Which 2 do you guys want to use?
5 and 3.
5 and negative.
Alright, 5 negative 8 and
3 negative 5.
3 negative 5. That sounds good. Does it matter which 2 points we use? Nope! Because we already know it's a constant rate of change. Alright. So I'm going to do my y's. So we chose negative 8 first, and then we got negative 5 right here. And then we got the 5 value for x first, and then the 3 value for x second.
That's the answer.
No, now we must operation. So, what's 8 minus negative 5? Bam, negative 3. What's 5 minus 3? Deuce. Nailed it. Alright, now let's find the rate of change, which is also kind of like rainbow method, right? We're going to make this a fraction like these, but I'm going to connect 2 points. Let's use 2 different points on this one. So what other point do you guys want to use? 7, negative 11, and which other one?
9 and 14.
Alright, let's do it. Okay. So I'm going to go downwards. So from negative 11 to negative 14. What would I do to negative 11 to get to negative 14? You're going to minus 3, right? So we're going to make that a negative 3 in the fraction. What about from 7 to old 9er? Yeah, right? You're going to have to, what the heck? There we go. Add 2, that's better. So that is our denominator, because that is the change in the x's, right here. So there's a 2 right there. And we got the same sloppage, no matter which way we done it. So let's point this out. So Megan points out that from negative 5 to negative 8, minus 3, minus 3, minus 3 through all of them. But just know that that won't always be that convenient for us. So they will mix that up sometimes.
Okay, thank you. Tell my parents that, please.
I did. All right.
Okay, thank you.
So again, let's do this using the equation V. What 2 points you guys want to use on this one? Sounds good. 319 and you nailed it, 1/9. So for my y value, I got a 19, and then the second y value was old 9er, right? So that gives me the change in y's. 19 minus old 9er is 10. Well, what about the other two values corresponding? We started with this x value of 3 going to this x value of a 1. 3 minus a 1 is deuce. 10 divided by 2 is 5. And if you wanted to make that 5/1, that's okay. Because it does show the rise and run this way. And that rhymed. That was pretty good. Alright, what about the rainbow method? Alright, well, let's use the other 2 points and just show that it doesn't matter which 2 points you use. So from 4 to 14, we're going to have to go upwards. How far upwards? 10. So that's my numerator, 10 over. From 0 to 2, you're going to go to the right 2, so that's a positive 2 right here. And this one also simplify to 5. And we got the same sloppage no matter which method we used. Alright, finding good old sloppage. We're going to have this fraction up in here with differences. Let's start, which 2 points you guys want to use on this one? First one, 0/9 and 3/9. Sound good. Well, the y value that we started with was old 9er, and then we went to old 9er, which is a difference of 0. Well, what about the x's? Well, we started with old 0, and then we went to 3, so that's a 0 minus 3, which is -3. 0 divided by -3 are 0, you guys. I mean, you can put that in a calculator if you need to, that's okay. What about good old rainbow method? Let's use the first and the last number, so 0/9 and 9/9. So from 9er to 9er, that's our numerator. We added exactly 0. So that is our numerator. And from 0 to 9er, that's to the right 9er, which is the denominator. 0 divided by 9 is 0. And behold, our 2 sloppages are the same. So what do you guys remember about 0 sloppage lines? What do they look like?
0.
Horizontal lines, right? So it would look something like these. So again, we'll use the equation stuff on this first one. So this is a subtraction right here. What 2 points you guys want to use on this one? Let's use the middle 2. We haven't tried that yet. So the first y value, I got a 12, and the second one I'll make it a 20. And then I got 2 x values, -3 and -3. So 12 minus 20 is -8. And -3 minus -3 is 0. So what's the sloppage right here?
A 0 with a line through it.
That's correct. 0 with the line through it, which means it is
Impossible.
undefined. Alright, what about the rainbow method? Which two? Which two do you guys want to use? Bottom two, bam. So the change in y's, 20 to 28, this looks like it's going to add 8. So that's 8 is our numerator. And from -3 to -3, you would have added exactly 0, which also is undefined. So again, the point of this is to demonstrate that it doesn't matter which method you choose, you will get the same sloppage either way. There they are, all 4 of them. By the way, number 4, what kind of line is it these? Vertical. So it'd be up and downer. Why are the slopes the same no matter what 2 points you use to find the sloppage? Here is why. Because, oh my goodness, okay, here. Because the rate of a change is constant. Bam. Alright, you may have written that it like on a graph it would appear as a straight line as well. It's not going to matter. Beans. Alright, cost. These cost $9 for 2 pounds. So in the table, right here, you see this $9, the cost? How many pounds can we get for $9? We already know that it would be 2 pounds because of what it says right here. Okay, now I've never been to a place where they charge variable amounts for variable pounds.
I have.
Well, I haven't, so take that. So we're going to assume that this is constant. Otherwise, it would make the problem extremely complicated, which I assume is what you want, for it to be as uncomplicated as possible.
Oh, no.
You got it. Uncomplicated. Sounds good. All right, so if I got $9, how much would half a pound cost right now?
2.25.
2.25?
I believe so.
Bam, very good. Now, how do we get that, though? Can I
I
grab it?
divided 9 by in half because to get 1, I divided that in half to get 125. Or you could just divide it by 4.
True.
All right, this is good. So you got $9. Let me see if and you can correct me if I'm explaining this wrong. $9, 2 pounds. Then you divided that in half to get 1 pound, which was $4.50. And then you divided it in half again to get half a pound for $2.25. All right, what do we call it when we have multiple equivalent fractions? It would be linear, but there's a little bit more to it. Equivalent fractions make proportional relationships. So these are all proportional. It's very good. By the way, in doing this, the way that Gavin did it, he's got this 450 per pound right here. That is the unit rate, which I'm sure we'll ask for later. So if it costs $4.50 for 1 pound, how much would it cost for 3 pounds? Bam, 13.5. By the way, I'm just going to put the dollars in this box. How much would 4 pounds cost? 18. Very good. How many pounds would we get for $27?
6 pounds.
There you go. 6, right? What about 8 pounds?
$36.
Very good. 10?
$45.
Yeah, 45. I had that backwards. And 20 pounds?
$90.
90. Good. What about for X pounds?
X. Well, I mean Y. It would have to be a different letter.
Nope. Think about what you're doing. You got that unit rate, right?
4.5.
You're on your way there. It is
For X, it would have to be Y.
4.5 times
X.
the number of pounds, X. Very good.
Wait.
Yes. Well, you know, if you have a extremely...
If you just have 9,000 extra bucks and you get 2,000 pounds of jelly beans.
Yeah, haven't you guys ever had like pork and jelly beans?
Pork.
It's good stuff, you know. You just throw some hot dogs in there, throw some jelly beans, mix it in some sauce. Some people like it over rice. I don't know, whatever you want, okay? I just don't like those jelly beans that taste like boogers. Those are kind of weird.
The one
Like, the last thing I want is to put a jelly bean in my mouth that tastes like pepper.
Oh,
Like, why do that?
bad.
I don't, yeah, why do it? Or butter.
No, they make it
Like, if I wanted butter, I would just go take a cube and take a chunk out. No problem,
I used
right?
to do that when I was.
All right, thanks for the feedback on the gourmet jelly beans.
Oh, skunks.
You guys like whatever you like?
State fair. My sister bought a box of those things, and as soon as I had skunk
Yeah.
it made me go over the edge.
Tasted so good.
For that descriptive
All right,
answer.
let's look at this right here. So we got to put a scale and a label for our x's. Now some of you guys remember that the x is the independent variable and the y is dependent. So which of these is dependent on the other? In other words, which came first, the chicken or the eggs? Well, as it turns out, you have to get the number of pounds, which will determine the cost. What this means is that the cost will depend on how many pounds of jelly beans. So, the pounds is independent. And then the cost, of course, will depend. The cost will depend on the pounds. So we'll label these right here in dollars. Now that we have those labeled, we need a scale. And for pounds, we can just let this be one each. So there's 2, 4, 6, 8, 10, 12. We'll just keep going. All right. Now the scale for our table, the cost goes as high as $90, which means I need to make this thing go up to, well, $90. So I'm going to make, actually, here's what I would do if I was you guys, is we can manipulate the scale to be whatever we want it to be. I mean, you could put this, every line is 10, which would get you up to 90. However, if I just make this go up by 9s, it would make this work a lot better. So, in other words, I'm going to make this first line old 9er, 18, 27. You guys heard that song on YouTube? 9, 18, 27, 36, 45. You know what I'm talking about?
No,
Math is fun or something like that. It's a great song.
I don't listen to it.
I listened to it. I've danced to it. It's great. Not that you guys wanted to think about that, but
I just hate the 2018 rap crap.
anyways. 54 is going all the way up. We may not make it to 90, it looks like. What did I do right? That's 63. Yeah, that's what happens when I didn't sing on that part. 72, 81, 90. You guys know it's got the crab and the whale? It's great. All right. Now that we've manipulated the scale to be exactly what I want it to be, but remember, it's not like I took the scale and then changed it as we went up. For example, I didn't go up 9 and then 10 and then 15 and then 36 or something weird like that. It's got, each line has to be worth the same amount. That is a great question. The pounds, since that's independent and the cost depends on the pound, it has to be the y-axis. If you put the pounds in the y-axis, you will lose points on a test. Or it would give you like a 2, because it demonstrates that you don't really know what the heck is going on. Okay? All right, now that we've got these, let's go ahead and put these points up in here. We got one at 2.9. See how this is going to work. 4.18. We had one at 6.27. 8.36. See how that makes that graph flow really well. We got one at 20.90 rather, and then we got a 10 at 45. Got it count? And we could see that if we followed this pattern, it would just go up on each of these grid intersections or corners. The next question is, you guys remember this one from the first lesson, hopefully, is, oh, let me ask you this before we get to that. How much would we pay for 0 pounds? $0. So we do have a point right here. It's important to identify that because now we can see that we have a proportional relationship. This is a straight line that goes through the origin on the graph. We already identified it on the table. So, what do we connect these points though? You guys remember how to tell? Let's look. Can we have fractional parts of pounds? For example, could I buy 0.5 pounds?
Yes.
Could I have 0.25 of a dollar? Yes, I could. So you're not restricted to buying just certain numbers of pounds. You could buy any number of pounds in between, going upwards. We do need the arrow right here as well. Then what is the sloppage of the line? Well, this is a proportional relationship. And we could see, if we wanted to, not that anyone ever really wants to, but if you go up niner, I'm going to choose these 2 points, and then go to the right 2, that gives us a sloppage of up 9 to the right 2, which ends up being 4.5 if you want the decimal. 9 over 2 can be reduced, so if you wanted to keep it that fraction, you could.
Wait, but aren't you not?
So this one is asking for sloppage. When it asks for a rate of change, then we need to make these labeled, because now we're looking at the context. So, write the slope of the line as a rate of change that describes what the slope means in this context. Let's use 9 over 2.
No, 2.
Well, it was $9 for 2 lbs. Pounds.
Thank you.
Okay? Now, if you wanted the decimal form of this, that would be fine. $4.5 or $4.50 for every 1 pound. It's up to you. Write an equation to find the cost for any amount of jelly beans. Well,
How much does a jelly bean weigh?
the cost we can see, actually we should write this, y is our cost because we can see that on the graph. And x is the pounds of jelly beans. Jelly beans. There we go. So, we'll figure out the cost, because it depends on the jelly beans. And we kind of wrote that up here on the table, right? The cost is already $4.50 times the number of pounds you get. That is all. That is all for the equation. You do need the y and the x there if you wanted full credit on the test, though. That would constitute a 4 type score. Gavin, please tell us. F.
Was it because they're all positive?
Oh, are you asking or telling?
Telling.
Yes, that is correct. So, let's kind of invert what you're saying there. Could we buy negative number of pounds of jelly beans? No, that would be weird. I mean, go to the store and say, look, I want to buy negative 15 pounds of jelly beans. They'll probably still charge you the actual price for 15 pounds of jelly beans. So there's no such thing. You can't buy negative pounds of jelly beans, Keith.
They take them all.
So that's very good.
Please don't do that.
No, I am willing to work with you on that, Kay. So, and then since that is what you told me you want, you can't go back on your words.
No,
All right.
I'm taking you. I don't want that.
You do want it.
No, I don't.
It's too late. Mr. Irving and Miss Hendrickson pay babysitters differently. Examine the table. Bam, I examined it. But what are the differences? Well, there's some clear differences. For example, if you were a babysitter and you work 0 hours, Irving is going to pay you nothing. But if for some reason they wanted you to babysit for 0 hours, Hendrickson would pay you how much? $4.
I'll babysit for you. Okay, I'm done. I didn't do anything. $4. Okay, I'll do it again. $4.
Actually, you got fired, so.
Oh.
Yeah.
It's
What about
half an hour?
what about 5 hours? How much did Irving pay?
$45.
$45 and Hendrickson?
44.
44. So since we can see that for 0 hours, Irving paid less and Hendrickson more, but suddenly at 5 hours, Irving more and Hendrickson less, somewhere in between they changed who was paying Mo and who was paying not Mo. So, are both relationships proportional? You guys remember how to tell on a graph if it's, a table rather, if it's proportional?
Wait, do we have to describe the difference on paper or?
Yes. What? That sounded good. So, yeah? Okay, whatever. All right, for example, let's look at Irving right now. Irving is going to pay you $0 for 0 hours. All right, that's undefined. That's okay. And then for $9 for every 1 hour for Irving, right? I'm doing Irving in red. And then for $27. You'll work 3 hours for Irving. What's 27 divided by 3?
9.
Niner. See how they're the same so far? What about $45 for 5 hours?
9.
$9 per hour is the rate. So right now we can see that Irving is proportional. But what about old Hendrickson? Let's find out. Hendrickson will pay $4 for 0 hours. That's undefined. That's okay. But what about $12 for 1 hour? That's going to simplify to 12. And $28 for 3 hours. 9.3 repeat on. So since we have those two values which are not equivalent, automatically we could say that Hendrickson is not proportional. So yes, Irving is proportional, Hendrickson is not. Bam, there it is. Alright, then we're going to graph these. And again, I will do Irving in red and then Hendrickson in old purple. But before we do that, we need to label the xi. Which of these is dependent? You either have monies or hours.
Y.
Yeah, y is dependent. What is the label for the y?
Money.
Yeah, right. Yeah, we can just put monies, costs, earnings, whatever you want to say there. They all kind of mean the same thing. Which means that the money will depend on the number of hours worked. Alright, now that we have those labeled, we need a scale. Hours, this one goes up to 5, so starting at 0, we got 1, 2, 3, 4, 5. And then the monies, the highest amount of monies we see is 45. So we can make this very specific to one or the other. How many lines do I got though? I'm going to actually make each of these go up by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Look at these. Alright, let's start with old Irving. Irving starts with $0 for 0 hours. And then 1 hour is 9. So that's just going to be below the 10 right account. And then 3 hours was 27s. So that would be right up in count. And then 5 hours rather is 45. Right account. Alright, what do we connect the points for Irving? We kind of have to determine how this is going to work, right? Usually people would be pretty nice and pay you, like if you worked half an hour, they'd just pay you the full hour's worth. If they're not, then they're kind of, I'd say they're kind of jerks about it, okay? So, I mean, some people would want to make this step up, something like these. I don't know, something like that. That's not what I want to do, though. So, I would just, I guess I'd leave this up to you guys. But I would put another point on there, right? If they work 2 hours, $18, and then 4 hours would be $36, something like this. So if you want to connect those, that's fine. Let's go ahead and just say we're going to connect them like these. Well, what about Hendrickson? Hendrickson is going to pay you $4 for the first hour. That's going to put us a point right account. And then 1 hour is $12. Which would be right about right account. 2 hours, or 3 rather. 3 is for $28, which is just above the red point right there. And then 5 for 44. Now it's below this red one. And again, we could connect these. There we go. That's a good question though, because we do need to differentiate between the lines. For example, if I wanted to, maybe instead of, because if I didn't have a purple marker, maybe I would make this one dashed, like this, something like that. And then one solid, and then I would label these. So I'd say red, this one is Irving, Irv. And then this one is old Hend. I didn't spell that right. There we go. Hend. Yep, so we do need to differentiate those on the test. That's very good. Alright, what is the sloppage of each line? Irving. Very good. Irving is 9. If we use the table, right, this is plus 9, and then plus 1 right account. Hendrickson, let's use these last 2 points. 28 to 44 is plus 16 over plus 2, right account, which would come down to 8. So it looks like Irving is paying $9 per hour, while Hendrickson is paying $8 for every hour. Write each slope as a rate of change to interpret its meaning. That's what we just did. There it is. Explain the different Y-intercepts. So the Y-intercept for Irving is at 0, 0, which we can see on the graph. We can see it in the table right here. What does that mean? Gavin?
Well, I just have a question.
Y-intercept stuff is telling us how much they started you at. Meaning that, let's say that Hendrickson said, you know what, I decided not to have you babysit. Here's $4. Bam. There you go. So the different intercepts, and also Irving's not going to pay you anything, which probably guarantees that he will leave the babysitter. Okay?
I would rather have.
So explain the different Y-intercepts. That is it. There we go. Is one babysitting job better than the other?
Until the 5th hour. Like,
Yeah?
Like just for doing like no hours, you basically have a $4 boost, but since he also he pays like one less than Irving. So if you go under 4 hours, then Hendrickson is better, but if you go over 4 hours, then Irving is better.
Good. What if you went exactly 4 hours? Then it's the same. That's very important to point out. If you work less than 4 hours, Hendrickson's your better deal. More, Irving, and exactly 4, just whoever you like the best. Okay? Maybe you can get Hendrickson to bump up that signing bonus kind of thing. Write an equation for each situation. Irving will be in red. Well, Irving, we're going to pay you, so that's our Y. So Y is the pay in dollars. So what do you get from Irving? Well, you got $0 up front. But then we're going to add $9 for every hour, which is going to represent it by X. X is number of hours. Alright. And we could calculate this. I mean, if you worked 5 hours, we already know that you'd make $45 from Irving. But it works in this equation as well. Same for 1 hour and 3 hours. And 0. Hendrickson, on the other hand, the cost or pay will be $4 up front plus the rate, which is $8 for every hour. So multiply that by the number of hours and you have how much they will pay you.